sub-hole is included in the square footage of the house for calculations in residential wiring. The sub-hole is considered an area of the house enclosed by roof and walls and accessed by a door, window, or other opening from the habitable portion of the dwelling. It is typically used for storage, utility, or maintenance purposes and has an average ceiling height of not less than 6 feet or 1.8 meters. According to the National Electrical Code or NEC, the square footage of a house for the purpose of determining the allowable load is calculated by adding the square footage of all habitable rooms, closets, hallways, bathrooms, and any other enclosed areas that are accessible from the habitable portion of the dwelling. This includes the sub-hole, as it is an enclosed area that is accessible from the habitable portion of the dwelling. When calculating the square footage for electrical load calculations in a residence, it's crucial to adhere to the guidelines outlined in the NEC. This code provides specific instructions on which areas should be included to ensure the electrical system is adequately sized and safe. The NEC methodology for calculating square footage is designed to account for all areas where electrical loads are likely to be present, contributing to the overall demand on the electrical system. Firstly, habitable rooms such as living rooms, bedrooms, dining rooms, and kitchens are always included in the square footage calculation. These areas typically contain numerous electrical outlets, lighting fixtures, and appliances that draw power. Secondly, closets, hallways, and bathrooms are also included in the square footage calculation. While these areas may not have as many electrical loads as habitable rooms, they still contain lighting and potentially other electrical devices such as bathroom fans or closet lights. Thirdly, any other enclosed areas that are accessible from the habitable portion of the dwelling are included in the square footage calculation. This provision is broad and encompasses various spaces that might not be explicitly mentioned elsewhere. The defining characteristic is that the area is enclosed by walls and a roof and is accessible from the main living areas of the house. The sub-hole falls under this category. The NEC approach to including all accessible enclosed areas in the square footage calculation is rooted in ensuring the electrical system can handle the potential load. By considering all these areas, electricians and electrical designers can accurately estimate the total electrical demand of the residence and select the appropriate size of service entrance, panel board, and branch circuits. Ignoring certain areas, such as the sub-hole, could lead to an underestimation of the load and potentially result in an overloaded electrical system, which can create safety hazards such as overheating, tripped circuit breakers, or even electrical fires. In addition to the general square footage calculation, the NEC also provides specific requirements for calculating the load associated with certain types of appliances and equipment. For example, ranges, ovens, clothes dryers, and air conditioners each have their own specific load calculation methods outlined in the code. These methods take into account the appliance's power rating and usage patterns to determine the appropriate load to add to the overall calculation. The general lighting load is typically calculated based on 3 volt amps per square foot as per NEC section 220.12. This value represents the minimum amount of power that must be allocated for general lighting throughout the residence. This method applies to most areas of the house, including habitable rooms, hallways, and closets. The NEC also includes requirements for calculating the load associated with small appliance branch circuits. These circuits, which serve countertop outlets in kitchens and dining areas, are required to be rated at 20 amps and are typically calculated at 1500 volt amps per circuit. This requirement ensures that these circuits can handle the load of multiple small appliances being used simultaneously. When calculating the overall electrical load of a residence, it's important to consider all applicable factors and apply the appropriate demand factors as permitted by the NEC. Demand factors are multipliers that can be applied to certain portions of the load calculation to account for the fact that not all electrical loads will be operating at their maximum capacity simultaneously. For example, the NEC allows for a demand factor to be applied to the general lighting load, recognizing that all the lights in a house are unlikely to be on at the same time. Similarly, demand factors can be applied to the load associated with ranges, ovens, and clothes dryers based on the number of appliances and their typical usage patterns. Applying demand factors correctly can help to reduce the overall calculated load and potentially allow for a smaller service entrance and panel board to be used. However, it's crucial to carefully consider the specific requirements of the NEC and to ensure that the applied demand factors are appropriate for the specific application. In some cases, applying demand factors may not be permitted or may not be advisable, particularly if the residence has a high concentration of electrical loads or if there are specific concerns about potential overloading. The NEC also includes requirements for calculating the voltage drop in branch circuits and feeders. Voltage drop refers to the reduction in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause appliances and equipment to operate inefficiently or even malfunction. To prevent excessive voltage drop, the NEC specifies maximum allowable voltage drop percentages for both branch circuits and feeders. These limits are typically 3% for branch circuits and 5% for feeders. When designing an electrical system, it's important to select conductors that are large enough to minimize voltage drop and comply with the NEC requirements. This may involve using larger conductors than would otherwise be required based on the ampacity of the circuit. In addition to the technical requirements for calculating electrical loads and voltage drop, the NEC also includes numerous safety requirements for the installation of electrical wiring and equipment. These requirements are designed to protect people and property from electrical hazards such as shock, electrocution, and fire. Some of the key safety requirements in the NEC include grounding and bonding, overcurrent protection, and wiring methods. Grounding and bonding are essential for providing a safe path for fault current to flow back to the source, which helps to trip circuit breakers or fuses and prevent electrical shock. The NEC specifies detailed requirements for grounding electrode systems, equipment grounding conductors, and bonding of metal enclosures and equipment. Overcurrent protection provided by circuit breakers and fuses is designed to protect conductors and equipment from overloads and short circuits. The NEC specifies the maximum allowable overcurrent protection for different types of conductors and equipment based on their ampacity and other characteristics. Wiring methods refer to the types of cables, conduits, and other materials that are used to install electrical wiring. The NEC specifies the acceptable wiring methods for different applications based on factors such as the environment, the type of building construction, and the voltage and current levels. When working with electrical wiring and equipment, it's essential to follow all applicable safety precautions and to comply with the requirements of the NEC. This includes wearing appropriate personal protective equipment, such as safety glasses and gloves, and using properly insulated tools. It's also important to de-energize circuits before working on them and to verify that they are de-energized using a voltage tester. In summary, the saw pole is included in the square footage calculation for residential wiring as per the NEC because it is an enclosed area accessible from the habitable portion of the dwelling. This inclusion ensures accurate load calculation and a safe electrical system. Remember to consult the latest edition of the NEC and local electrical codes for specific requirements and guidelines. Always prioritize safety and consult with a qualified electrician when working with electrical systems.